Hey guys, it's Mr. Calderon with Queen My Pawn, and today I'll be discussing how to use Python as a calculator. So most of it's really easy except for just a couple of things. So let's go ahead and see what that looks like in Python. So Python knows its order of operations, it knows addition, subtraction, division, multiplication, and all that cool stuff. The things I want to discuss about are a bit under the radar. So first, let's say that I have something like 8 divided by 5, or 8 divided by 5, right? Then I get 1.6. If I wanted to get just the ones digit, I do this thing called floor division, and that would just give me the 1. And if I want the remainder, which would be 3, then I do 8% 5, and it'll give me 3. Now, that's basically it for using Python as a calculator, but let's say that I wanted to work on the last entry. Well, I have this cool thing called the underscore, right? And it'll actually give me the last entry. But one of the things you want to do is be careful not to assign underscore something else like str, for example, a string literal. And if you try to use underscore again, like 3, like let's say I want to do 5 plus underscore. Now, will it give 5 plus 3 or 5 plus whatever you assigned underscore? Well, when you assign underscore to something, it takes away the magical power. So you're going to get an error because you're trying to add the integer plus a string. That's why you don't assign underscore to anything. I mean, you can make it work by doing putting 5 as a character, and then you get that. But in order to avoid any bugs or messes, bugs being annoying things in your code that you don't want there, you don't want to assign underscore to anything. Now, the real point of this video comes right now. So let's say that I have something like 1 over 10. It'll give me 0.1, right? But in case you didn't know, computers work as either something's on or something's off. It likes to use switches, okay? So let's say that off means 0 and on means 1. That's actually how computers started to work, because when you have that simple logic, then everything else becomes easy. But how does that look like here? Well, if you were to write a number like 5 in binary, you would actually make it equal 101. Now, what does that mean? Binary means something's either on or off, right? So in other words, you only have 2 numbers, 0 and 1. So that would actually be 1 times 2 to the second plus 0 times 2 to the first plus 1 times 2 to the 0. And actually, this correct, we'll assume it means power. And so basically you have 1 times 4 plus 0 times 0 plus 1 times 1, which gives you 5. So that's how 5 looks in binary. And if we have something like 10 in binary, well, that's just 8 plus 2. And luckily for us, 8 and 2 are powers of 2. So you get 1, 0, 1, 0. Because this number is 1, that number is 2, that number is 4, that number is 8. 8 and 2 are on, so 8 plus 2. 4 and 1 are off, so 0 plus 0. And if you have something like 1, 1, 0, 1, well, that would be 1 plus nothing plus 4 plus 8, which is 13. That's a brief introduction of binary. And actually, you could do decimals in binary as well, as long as they're powers of 2. So for example, let's say you have something like 0.25. Well, that's just 1 over 4. And 4 is a power of 2. So you would have 1 over 2 to the second power. And actually that's just 2 to the negative 2, because that's the rule. So I erased that by accident, so I'm going to retype it again. 125 equals 1 over 4, which equals 1 over 2 to the second power, which equals 2 to the negative second power. So in binary, that looks something like 0.01. But what if you have something like 0.3? That's not a power of 2. The only thing you can do with 0.3 is approximate it. So here's how you approximate a decimal in binary. If you have something like 1 over 2, that's too much, right? So we could do 1 over 4. Now, what about 1 over 4 plus 1 over 8? The next biggest power of 2. Well, that would be too much if you use a calculator. You'll find out it's too much. But what about 1 over 16? The next big power of 2. If I put that in my calculator, which I will right now, I'll get 1 over 4 plus 1 over 16, which is still too much. So I'm going to do 1 over 32 instead. And yeah, that works. So it'll give me some number that's smaller than that, but close to it. And so I keep going. So far, our best approximation is this 0.01, 001, and so on. That's why you can't really represent decimals as exact in when you divide. But why does 1 over 10 look like that? Well, the computer has gotten really good at cutting off all the extra fat off. So let me show you something really cool. So Python has a library called decimal. And when I use this library, I'm going to call upon a function that will tell me what exactly 0.1 looks like. And that's what it looks like. We've approximated it to that. And you can see that this is the fat that I was talking about. So whenever you have floating point numbers, that's what they're called, because you can float the points. As in, you can put the point there, but then divide it by 10 and so on. Or multiply by 10, I mean. When you have something like this, 0.1 times 3, you're going to get this number. It's not exactly 0.3. So when you try to do something like 0.1 times 3, and then you try to test it for equality, it's going to get false. But when you have something exact, like 0.25 times 2, now both of these are powers of 2, so no doubt it's going to give me that it's true. So you see? So that's the interesting thing about using decimals. They're not exact unless they're powers of 2. In some cases, the computer gets really good at approximating it, but you have to be wary about those limitations with floating points. So I'm really glad I got that out the way for you guys, because that leads us to this, the round function. So let's go ahead and look at this. Round 0 or 0.1 to 30 places. Well, like I said, it's gotten really good at chopping it off. But let's say I make my bar equal decimal of 0.1. Now I'm going to do round of bar to 30 decimal places, and it doesn't let me do that. I guess I can't call it round on those objects, because when I look at the requirements for rounds, it has to be a number. And I guess decimal isn't a number that's allowed to put in there. So I guess that's it. That's all I wanted to talk about in this video. If you liked the video, make sure to click the like button. Also click subscribe for more content like this, and I'll see you in the next one.